14.4, more moving graphs around. Here are 5 equations and 4 graphs. So the point of this activity is to match each equation with a graph. One of the equations is not pictured in the graphs. So for that one, you got to fill in the blank graph right here. So the first thing I'm going to do is, since these are all in that vertex form for absolute value, so I'm going to write out here the general formula. Y equals x minus h plus k, where h comma k is the vertex. All right, you could put a value a here. That will make the absolute value have a steeper or more narrow slope, sort of similar to how we had wider or more narrow parabolas. But all these just have a value of 1 in front, so I'm not going to make it overly complicated. So for this one, there's no y value, it's really a plus 0. So, no k value, I should say. So this center is 3, 0. Equation 2, 9, 3. And if you'll notice here, it's a minus h. So whatever number you see here, even though it looks like a negative 9, I'm just going to write positive 9 right here. Here, there's no h value, or it's 0, and that's a negative 6. The k value is exactly how it appears to be. Here we've got negative 3, 0, and here we've got negative 3, negative 6. All right, so now because I know the vertex, it'll be easy to find my to find which absolute value function correlates. So let's see. Equation 1 actually, I believe. Oh no, that's good. That one's good. That is for graph B. I can see my vertex here is 3, 0. So those match up. All right, equation 2, I'm looking for 9, 3. Well, that'll be right here. So D goes with equation 2. All right, equation 3, 0, negative 6. All right, well, I see both of these have negative 6 as the y value, but this one has 0 as the x value. So I'm going to go with A for equation 3. So right here we've got 0, negative 6 is my vertex. Equation 4, negative 3, 0. Now this one I don't see anywhere. I see negative 3, but the y value is negative 6, so that's going to be for equation 5. So equation 4 is my missing graph here, E. So now I'm going to graph that. So another way you can think of graphing this is we're shifting it 3 units to the left, the normal absolute value function. So I'm going to start my vertex right here at negative 3, 0. And then my scale in the x and y direction is 3. So even though my slope is going to be up 1 over 1, and the scale is larger than that, it's 3, it's like going up 3 over 3, which is the same as going up 1 over 1. So that slope is going to look the same. And now it's just the negative slope. All right, and these are all very easy to check on my graphing calculator. I don't know why they didn't include arrows here. I'm going to include arrows on mine because that's good practice. Maybe that's not something they think is super important, but I think it is. Okay, so it'll be really pretty easy to check these on the calculator. All right, let's see how that's showing up. Good. All right, so what we're going to do is first I want to set my window so that it reflects the graph that they gave me. So if I look at my x min and max, I've got negative 12 to 12. That's sort of like the domain for this graph, even though it extends till negative infinity and positive infinity. For this like snapshot, I just need from negative 12 to positive 12. All right, x scale. Well, this x scale goes up by 3, so let's make that our x scale. Y min is -12, Y max is 12, and the scale is 3. All right, so now if I go to my graph, my graph should look just like, and I can see it's 3, -3, -6, -9, -12. And now I've got some parabola from our previous problem. I'll take that off. My scale now is the same here as it is on this graph. So what I'm going to do is go to y equals, and there's a special way to put in that absolute value function. So what you're going to do is you're going to hit the math button right here. Let's see if I can find it. I kind of forgot exactly where it is. There it is. So if you go to math, then go over to the right column, number, and then that first value that says abs, that stands for absolute value. So this is very much like the radical. Whatever you put in the parentheses gets absolute valued. So for equation number 1, it's x minus 3. So I'm going to put in x minus 3. And then I'm going to close my parentheses. All right, so if I look there, this is supposed to look the same as b, and I can see that even though it's not exactly the same, because my calculator is a little bit wider, and this is like a perfect square, I can see the shape, like where the vertex is the same as this graph. All right. Next, equation 2. So that one I'm just going to rewrite. I'm going to put a 9 there instead, and then a +3 here at the end. All right, and that should match up with D. And I can see that these two do look very similar. Let's see if I can make that a little clearer. Yeah. Great. All right, equation number 3, absolute value of x minus 6. I could keep that plus there, but I'm going to change it to just -6. Okay, I would have to actually make it plus -6, so it's good that I took it away. And this should look like this equation right here. I mean, this graph for A. All right, those do look very, very similar. All right, equation 4 is absolute value of x plus 3. And that should match up with E, the graph I made. All right, and I can see that they both have that same vertex here. All right, and lastly, equation 5, absolute value of x plus 3 minus 6. And that should match up with C. And we can see that these two do match up there. All right, have a great day.